Let's discuss TCN part C, question number 7. Generally it is coming two type of new question. One is identify the star, one is find them, another is the type of that star and planet available for observation. These two type of numerical comings. Okay, so today we are going to discuss identify the star and planet. So generally it is almost it is all the time it's only star. The one or two numerical is there, but they are changing the values here and there. So I am going to solve two numericals. So just the other numericals is just the value changes. So you can calculate and you can verify your answer with the write me in comment box, so I can verify your answers. Okay, this question is coming from 25 marks and it's very simple and very short. So if you understand this question, it's very easy, and you will finish in 15 minutes this question, and you will easily score 25 marks, so that you can go that you can occupy that time in the chart works numericals. So as I told you, this identify the star, this repeated question is coming 6th April 2020, then May 22, September 21, November 17, January 17, October 16, Jan 16, November 15 and July 18. So this is repeated question. So the diagram you see, it is PZX diagram. So PZ is, as we know that PZ is our latitudes, ZX is zenith distance, and we need to find out PX, and declination is 90 minus px. We are going to solve this numerical. When we solve, we will again make this diagram and we'll see how we'll make this diagram and how we'll proceed. So generally in the identify the star, we need to find two things. One is declination and one is SHA. When we have both these two values, we can go to almanac in 1992 and we can check with the date which star is matching with that declination SHA, and that is our star. Okay, so the procedure is, first we have to find out the find and declination SHA of the star. Then we have to go to see the nautical almanac. Okay, in this type of numericals, you always found in the question times, azimuth and bearing, sextant altitude, and dr lat and dr long. So in this all this given and they ask the identify the star, that means you will easily understand this is this type of numericals. So how to find? First we have to find true altitude, then true zenith distance, which is 90 minus true altitude, then GHA of Aries and LHA of Aries, and we use the cosine formula here. So we already, it is a cosine formula how to use and what is the how to remember. It is given in my grade circle sharing videos, so you can, if you not able, you can go to watch the grade circle sharing formula videos, so you will able to collect this cosine formula. So px is, when we find out the px, and then we can find out the declination, because declination is 90 minus px, and then we find out the p, LHA of Aries and SHA of star, and when we both have the declination SHA of star, we can find out the identify the star. How to find declination? Okay, first we have given in the question zenith, azimuth, which we convert in quadrantal angle. Then Zx is equal to 90 minus true altitude, which is zenith distance. So Pz is equal to 90 minus dr latitude, and we use the cos px formula to find out the side, cos z into sin pz into sin zx plus cos pz into cos zx. Then we find out the px, and then declination is 90 minus px. How to find p? Then we use the p angle formula, cosine. So cos zx minus cos pz into cos px divided by sin pz into sin px. Cos inverse, we find out the p, and we have to find out the LHA of star. That is, if it is less than 180 degree, the p is equal to LHA. If it is more than 360, then LHA is equal to 360 minus PD, which we already discussed. SHA of star is equal to LHA of star minus LHA of Aries. Okay, to calculate declination and SHA of star in the daily page of the almanac to identify the star. So this is a basic, all this we required in this type of numericals. Now we are going to solve the question which is coming in November 15. Okay, November 15. We are going to solve these two numericals. If you are able to understand, it's very simple. I will give you all the questions, you will solve. You can write me your answer in comment box, so we'll verify, and hardly if you 2 or 3 solve, your 25 marks in your pocket. Okay, the first question is, on 20th Jan 1992 am at the ship in DR position 25 degree and 28 minutes south and 107 degree 14 minutes east, the sextant altitude of unidentified star bearing 214 true was observed to be 35 degree 42.8 minutes when GMT was 21 hour 29 minutes 24 seconds. If the height was 31 minutes and index error was 2.2 of the arc identifies the star. So you have the, as I told you, you always given time. So you have the GMT time, you have the azimuth bearing, so you have bearing, you have the sextant altitude which is already here, then also you have the height, index error which is required to calculate true altitudes, and we have the DR position, latitude and longitude. Okay, so these things is given in the question, and identify the star, that means this is this type of numerical. So let's see how we'll move this question. Okay, so first of all we have to make PZX diagram. Okay, so let's make PZX diagram. Okay, so it is south, so our pole will be in south side, so the equator will be go in the north side. Okay, put the name north, south, east, west. Okay, and this is our pole. Okay, now what it was given, the bearing was 214. That means our Z is here, equator is here, and 180 is here, this 180, so 214 is around here. Let's say this is our body, so join this. So this is our azimuth. Okay, this is our body, and now we have to solve this question. Okay, so let's see what is given in the question. We have the bearing 214 true, so we have to convert into quadrant form. So south 34 degree west. Okay, so Z is equal to 34, this is 34. Now we have the DR lat 25 degree 28 south, so we can find out the PZ, which is 90 minus DR latitude. So 90 minus 25, 28. So we get 64, 32 minutes. Okay, this much is clear. Now we have the GMT time, but we have to verify the GMT times. Okay. So day, hour, minute, second. We have to do because we have to step marking, and so we have to verify. Okay, so we have GMT time is 21 hour 29 minutes 24 seconds. We have the LIT East GMT list. Okay, so plus 070856. So this is 04 38 20 and this 20. So this is 90s. Okay, that means our GMT is date is 19. So we get the GMT time is 29th Jan, 21 hours 29 minutes 24 seconds. Okay, now we have the sextant altitude. Okay, sextant altitude was 35 42.8 is given in the question. Index error off, that means we are going to use plus sign. Add, so we get the observed altitude 35 degree 45.0. we have the deep is 31 meter, so we can go and find out in the almanac in the first page. So we get the 9.8 correction. So we get the apparent altitude is 35.2. now we have to find out the total correction of the star, so which is 1 minus. So we get the true altitude 35 degree 33.8. now true zenith distance is 90 minus 2 altitude, so 90 minus 35 degree 33.8, so we get 5426.2. so since we know that zenith distance is equal to TJD, so we get the ZX is 5426.2. okay, this is one side. Now other side we have GHA of Aries from the almanac 7330.9 by GMT we get. So we have to now increment 007 degree 22.2, add, so GHA of Aries we get 080 53.1. now we have the DR longitude east, so this is list 107 14.0, add, because so we get the LHA of Aries 18807.1. this is clear. This is all we are using from the second mate. Okay, now we find out the declination. Okay, find out declination, that means we need to find out the px, because 90 minus px is equal to, so let's see, we need to find px. okay, we have angle z, we have zx. okay, so we have the angle p, so we can find out, so we have the pz, this angle z, px, so we can find out 3. so we have the one angle and 2 sides. okay, so use the cosine formula. okay, we make diagram here, one more, this is z, this p, this x. so we have the angle z. okay, we have pz, we have zx, so we can find out px, and when we find out px, then 90 minus px we get the declination. okay, so use the side formula, cos px is equal to cos z, then sin zx into sin px plus cos zx into cos px zx. okay, now put the value, so cos 34 into sin 64 degree 32 minute into sin 54 degree 26.2 plus cos 64 32 minutes into cos 54 degree 26.2. So we get 0.858953 cos inverse px is equal to 30 degree 48.1. Okay, so declination is equal to 90 minus px. So 90 minus 30 48.1. So declination we get 59 degree 11.9 south. Okay, the first part is clear. Now to find out P. Okay, now we have to find out this angle. Okay, so zx, we have zx, we have pz, and we have px. All three sides we know, so we can find out the angle. Okay, to find P, so we use the cosine formula. Cos P is equal to cos zx minus cos pz into cos px divided by sin pz into sin px. Okay, so put the value cos 54 26.2 minus cos 64 degree 32 minute into cos 30 degree 48.1 divided by sin 64 degree 32 minute into sin 30 degree 48.1. So we get 0.45943. So cos inverse, we get the value of P 62 degree 40.1. So it is less than 180 degrees. So LHA is equal to P is equal to 62 degree 40.1. So SHA of star is equal to LHA of star minus LHA of Aries. So 62 degree 40.1 minus 18807.1. So we get 23432.9 SHA of star. Now we have declination 59 degree 11.9 south, SHA of star 23432.9. Now we go to the on the almanac 19 Jan, and the left side we have the stars, so we can find out the star is ever. This is our star, identification of the star. Okay, so this is very simple. Let's move to the next question. So our next question is coming in July 18. On 15th June 1992, during PM twilight, our on ship position dr latitude, dr longitude given. So one condition satisfied. Sextant altitude also unknown star was 227 degree 3/4. True was, and index error was given. Index error is given. Height of I is given, and GMT time is given, and identify the star. Okay, so let's move this question. First of all, we have to make the PJX diagram. Okay, so latitude north, so equator will be go this side. Okay, north, east, south, west. Okay, and we have the 227, so 180 227 here. So this is our pole. So let's say body is here. This is zenith, this is Q. This angle Z, P, and this is our body. Now what is given in the question? Bearing. Bearing was given 227 3 to the power 3 by 4. So we have 227.75. Okay, convert in quadrantal form. So south 47.75 west, which is 180 minus 47.75. So we get 133. Now we have the DR latitude 36 degree 10. So we get bearing 133. To find in quadrant form, DR latitude we are given 36 degree 10 minute north. Okay, so PZ is equal to 90 minus DR latitude. So 90 minus 36 degree 10, so we get the 53 degree 50.0. Now we have to verify this GMT times. So hours, minute, second, GMT 22, 43 and 45 second. LIT is given west, so GMT list. So 030800 minus 1935.45, so 15. So we have the GMT also 15. So GMT we get 15th June 22 hours 43 minutes and 45 seconds. Now we have to put sextant altitude, calculate sextant altitude. So 6102 minutes. Index we have on, so minus 0.5. Okay, 0.5. So we get the observed altitude by subtracting 6101.5. Deep almanac from we get deep value minus 4.5. So we get apparent altitude 60 degree 57.0. Total correction minus 0.5. So true altitude we get 60 degree 56.5. 90 minus true altitude, true zenith distance 2903.5. So zenith distance is equal to ZX 2903.5. Here we have GHA of Aries is equal to 234. From almanac we get increment 010 58.0. So GHA of Aries add 245 23.9. DR longitude west. So this one is list GHA. So LHA of Aries 198 23.9. Okay, now we have to find the declination. To find so cos Z px is equal to cos z, same cosine formula, sin pz into sin zx plus cos pz into cos zx. Put the value cos 132.25 into sin 53 degree 50 into sin 29 degree 03.5 plus cos 53 degree 50 into cos 29 degree 03.5. So we get the value 0.783270. So cos inverse, we get the px value 75 degree 23.5. Now declination is equal to 90 minus px. So 90 minus 75 degree 23.5. So we get 14 degree 36.5 north. Now to find P. So cos P is equal to cos ZX minus cos PZ into cos PX divided by sin PZ into sin PX. So put the value cos 29 degree 03.5 minus cos 53 degree 15 into cos 75 degree 23.5 divided by sin 53 degree 50 into sin 75 degree 23.5. So we get the P value 21 degree 48.6. So P is equal to LHA is equal to 21 degree 48.6. SHA of star is equal to LHA of star minus LHA of Aries. So 021 48.6 minus 198 23.9. So we get 183 24.7. So we have that find out the declination 14 degree 36.5 north. SHA of star we find out 183 24.7. So our star is Denibola. So this is our answer. Okay, this also I give you this question. Okay, now I give you 5 more question. This is very similar to this question, only the value is changes little bit here and there. So you do the same procedure and you can verify your answer in the comment box. So for you, this question number 1, this question number 2, question number 3, question number 4 and question number 5. So when you write in answer in comment box, so write the question number also. Here is the same thing, nothing is different. So here 276 gyro was given and error was 2 degree low. So you have to calculate 2 true. Okay, so gyro low, error low to gyro low, so you will get true. You have to calculate true. And one more miss in the third question is this is 43 degree. Okay, it's not 430, that correction is there. Then rest is same. Yeah, rest is same. So you can solve anything, any question, and if you want to verify your answer, write me in comment box with the question number. And hope you understand this very simple identification of the star numericals, which is coming for 25 marks, part C, question number 7. So all the best for your exam. See you in the next video.